Okay, we're moving on to our last section of Unit 6, so let's dive into it. Our learning targets for this lesson is to interpret type 1 errors and type 2 errors in context and give consequences for each type of error, and then also interpret the power of a significance test and describe which factors affect the power of a test. When we draw a conclusion from a significance test, we hope our conclusion will be correct, but sometimes it'll be wrong. There are two types of errors, and the first type is called type 1 error. It occurs if we reject the null when the null was true. That is, that the given data is convincing evidence that the alternative is true when it really isn't. And then the second type is type 2 error. That occurs if we fail to reject the null when the alternative is true. That is, that the data did not give convincing evidence that the alternative is true when it really is. Let's get some concrete examples to better understand these types of errors. So this matrix might help you a little easier to understand. So if you notice here, if we reject the null when the null was true, that's a type 1 error. But if we reject the null and the alternative was true, then our conclusion was correct. If we fail to reject the null when the null was true, that's perfect. We got a correct conclusion. If we fail to reject the null when the alternative was true, then that's a type 2 error. Now, which is worse? It all depends on the problem. Sometimes a type 1 error is more impactful than a type 2 error. And this really has to do with, not the math so much as the context of the problem. So going back to our jury verdict that I talked about before, if our null hypothesis is not guilty and the alternative was guilty, a type 1 is a false positive. So the person's not guilty, but the court convicts them as guilty, which means an innocent person is wrongly punished. A type 2 error is a false negative. The person is guilty, but the court declares them not guilty, which means a guilty person goes free without punishment. So in essence, in this problem, type 1 error harms the innocent and type 2 error allows the guilty to escape justice. Now let's look at this problem. The potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of 500 potatoes from the shipment. The producer will then perform a test at the alpha level of 0.05 significance level. Our null hypothesis, and we're talking about proportions, so P is equal to 0.8, and our alternative is that P is greater than 0.08. So remember here I said convincing evidence that more than 8% of the potato chips of the potatoes in the shipment have blemishes. So that's why we're putting a greater than symbol there, where P is equal to the true proportion of all potatoes in the shipment with blemishes. Describe a type 1 error in this setting and give consequences. So let's remember, a type 1 error is when we reject the null when the null was true. That's a type 1 error. So here, the supervisor finds a convincing evidence that more than 8% of the potatoes in the shipment have blemishes, when the population proportion is really 0.8. That's when we reject the null, but the null was true. That's a type 1 error. And a consequence could be that the potato chip producer sends away the truckload of acceptable potatoes, wasting time, depriving the supplier of money, so he's wasting precious time that he could be continuing sending truckloads of potato chips to other suppliers. So now here they want us to determine a type 2 error in this setting. So if you remember, a type 2 error is when we fail to reject the null when the alternative was true. Okay, so we failed to reject the null when the alternative was true. That's a type 2 error. So here the supervisor does not find convincing evidence that more than 8% of the potatoes in the shipment have blemishes when the population proportion is greater than 0.08, which is the alternative. So consequence could possibly be more potato chips are made with blemished potatoes, which may upset the customers and lead to decrease of sales. So that could be an option of a consequence there. So if type 1 error is really scary to you, then you need a small significance level, like a 1%. Okay, so like the alpha level of 0.01. So if you want it to lower the probability, you need to lower your significance level here. So which one of these is the best choice for a significance level? That really does depend whether type 1 or type 2 error is more serious. Okay, so a type 1 error probability is a probability of type 1 error in a significance level is equal to the significance level of the alpha there. So when we decrease the probability of making a type 1 error in a significance test by using a smaller significance level, but there is a trade-off between the probability of the type 1 error and the probability of type 2 error. As one increases, the other is going to decrease. So if we make it more difficult to reject the null by decreasing the alpha, we increase the probability that we will not find convincing evidence for the alternative when it's true. So what that blue box is saying is if you decrease the significance level in order to decrease the probability of type 1 error, you're actually going to increase the probability here of making a type 2 error because it's going to be hard for you to find evidence that's convincing. Now, the power of a test is used when researchers often perform a significance test in hope of finding evidence for the alternative. Now, researchers would make a type 2 error if they fail to find convincing evidence for the alternative hypothesis based on the sample data. What they're saying is that they didn't find convincing evidence, but it turns out that in real life, it actually should have been rejecting the null hypothesis. They should have found convincing evidence, but they didn't, which is called a type 2 error. Now, how likely is a significance test to avoid a type 2 error? We refer to this probability as the power of a test. So the power of a test is a probability that the test will find convincing evidence for the alternative when a specific alternative value of the parameter is true. So again, here relating the power and the type 2 error, the power of a test to detect a specific alternative parameter value is related to the probability of a type 2 error for the alternative. This is only the type of calculations you'll be asked to calculate when finding the power of a test. So here we have the power is equal to 1 minus the probability of type 2 error. And doing the math here, for the probability of a type 2 error, well, that's going to be 1 minus the power. So here they will either give you the probability of the type 2 error to find the power, or they'll give you the power to then find the probability of a type 2 error. Now let's look at this problem here about the company that developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. Based on years of experience, the company's regular AAA batteries last for 30 hours of continuous use on average. The company plans to select a simple random sample of 50 deluxe AAA batteries and use them continuously until they are completely drained. Then it will perform a test at the alpha level of 0.05 significance level of, now they tell us what the null, which is the mean is equal to 30, and the alternative is the mean is greater than 30. Now notice here they're using mean and not proportion, but that's okay. it will still work the same way, okay? Where the mean is equal to the true mean life in hours of the deluxe AAA batteries. The new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. The power of the test to detect that the mean is equal to 31 hours is 0.762. Interpret this value. So notice they are giving us our power test here. Power of the test, which is 0.762. So we're going to go ahead and interpret that value. So interpreting the value here, it says if the true mean lifetime of the company's deluxe AAA batteries is the mean is equal to 31 hours, there is a 0.762 probability that the company will find convincing evidence for the alternative, which is the mean is greater than 30 here. Now, this is some calculations that they can ask to find for the power test. So notice in the previous example, it's actually asking you the probability that we reject the null given that the mean is 31, and that was 0.762. They would have to give that to you unless they phrase it like this. So what's the probability that the company makes a type 2 error? That's the probability that failing to reject the null, given that the mean is 31. So type 2 error is the complement to the power value. Now this should make sense because the definition of the power test is the probability that they will avoid a type 2 error. So the complement of that would be that they will make a type 2 error. And notice that it's going to be 1 minus 0.762, and that's how we get that. And this is going back to our previous slide on how we found the power and how we found the probability of type 2 error using the power of a test here. So let's look at this problem. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after placing an order. Based on store records, the proportion of customers who had to wait longer than 2 minutes was P is equal to 0.63. To reduce this proportion, the manager assigns additional employees to drive-through orders. During the next month, the manager collects a random sample of 250 drive-through times and finds that P hat, which is our statistic, is 144 over 250. The manager then performs a test of the following hypothesis at the alpha of 0.10 significance level. So our null hypothesis is here is P is equal to 0.63. Our alternative is that P is less than 0.63. Where P is a true proportion of drive-through customers who have to wait longer than 2 minutes to receive their food. Now it says describe a type 1 error and a type 2 error in the setting. Which type of error is more serious in this case? Justify your answer. And based on your answering question 2, do you agree with the company's choice of the alpha level 0.10? Why or why not? And then the p-value of the manager's test is 0.0385. Interpret the p-value here. So let's look at the first one. Describe a type 1 and type 2 error in the setting. So a type 1 error is that the manager finds convincing evidence that less than 63% of the drive-through wait times are longer than 2 minutes when the true proportion really is 0.63. So remember what a type 1 error is. And a type 2 error is that the manager does not find convincing evidence that less than 63% of the drive-through wait times are longer than 2 minutes, when the true proportion really is less than 0.63. And then in the next part, it says, in this case, a type 1 error is more serious because the manager will believe that the additional employee reduces the proportion of drive-through customers who have to wait longer than 2 minutes to receive the food, when in that, it's not the case. So here, type 1 error would be a little bit worse. And then in question 3, it says, no, if the null hypothesis is true, a significance level of 0.10 will result in a type 1 error, which is 10% of the time just by chance. Because a type 1 error is more serious in this case, it would be better to pick a smaller alpha, like 0.01, a 1%. Okay, and then question 4, It says, assuming that the true proportion of all drive-through customers who have to wait longer than 2 minutes to receive their food after placing an order is 0.63, there is a 0.385 probability of getting a sample proportion of 0.576 or less who have to wait longer than 2 minutes just by chance in a random sample of 250 drive-through customers. So that's interpreting our p-value there. So what can researchers do to decrease the probability of making a type 2 error and increase the power of the test? So here, when the null is false and the alternative is true, a significance test based on a random sample of size n and significance level of alpha will have a greater power and a smaller probability of making a type 2 error. Wow, that was a mouthful. All they're saying is, how do we increase the power of a significance test? So how do we increase it? Well, we're going to get the sample size n and make it larger. Or we can get the significance level, or alpha, to be larger. Or we look at the null alternative parameter values are farther apart. And then the last one is that our standard error of the statistic is smaller. So let's look at a problem here. So the researcher in the Alzheimer's experiment wants to test the drug manufacturer's claim that fewer than 10% of the patients who take its new drug for treating Alzheimer's disease will experience nausea. That is, they want to carry out a test where the null hypothesis, p is equal to 0.10, because that's the 10%, and the alternative is that the probability is less than 0.10. Where p is a true proportion of patients like the ones in the study who would experience nausea when taking the new Alzheimer's drug. Earlier, we mentioned the power of the test to detect the p is equal to 0.08 using a random sample of 300 patients and a significance level of alpha, which is 0.05 is 0.29. Now notice the power is 0.29. That's very low. Determine whether each of the following changes would increase, decrease the power of the test, and explain your answer. So let's look at the first one. So let's look at the first part. When the alpha level goes from 0.01 instead of 0.05. So if we change the significance level to something smaller, it's going to decrease the power. So using a smaller significance level makes it harder to reject the null when the alternative was true. Then if the true proportion now decreases from the p-value from 0.08 to now 0.06, that makes it more extreme. So it's going to increase the power here. So it's easier to detect a bigger difference between the null and the alternative parameter value. And then the last one is when the sample size decreases from 300 to 200 here. And decreasing the sample size will make the power worse. So it's going to decrease it. A smaller sample size gives less information about the true proportion here, which means if you've decreased the power, that means you've increased the probability of making a type 2 error. So we have decreased the probability of a type 1 error, which remember we talked about before, sometimes we would rather make a type 1 error versus a type 2 error, or the opposite might be true. It all depends on the context of the problem. So going back to the potato chip supplier that we did before, our question here is going to be to interpret the value. If one shipment is 11% of the potato chips have blemish, in this case, the power of the producer's significance test is 0.764. So they want us to interpret what that value means. So if 11% of the potatoes in the shipment have blemishes, there is a 0.764 probability that the producer will find convincing evidence for the alternative, which means that the p-value is greater than 0.08. Let's look at this problem here. It says, still talking about the potato chips, shipment. So how will the power change if the producer uses the alpha level of 0.01 instead of 0.05? So just making sure that we understand what happens when the alpha level is decreased. So if the alpha level is decreased, the power will decrease, which means decreasing the significance level from 0.05 to 0.01, it makes it harder to reject the null when the alternative was true. Now let's look at this one. How will the power change if we actually use a sample size of 1,000 instead of 500? So now we're increasing our sample size. What happens to the power? So here the power will increase. Increasing the sample size from 500 to 1,000 gives more information about the population proportion P. And that should make sense because we've talked about increasing our sample size will yield closer to our population value there. And then on this one, it says another shipment only had 10% of the potatoes having blemish. Assuming the producer selects a random sample of 500 and uses an alpha level 0.05, how will the power compare to the shipment of 11% blemish potatoes? So notice that we talked about 10% and we're going to compare it to the 11% blemish potatoes. So the power will decrease. It's harder now to detect a smaller difference, so 0.02 versus 0.03, between the null and the alternative hypothesis. And this were our learning targets. So hopefully we'll work with this more in class, but we learned how to interpret a type 1 and a type 2 error and look at consequences. And we also learned how to find out about the power of a significance test and describe which factors affect the power of a test. And that is it for Unit 6.